ladies and gentlemen. Good morning, afternoon, morning to you. Hearing bells. I think that's my email. Anyway, the internet's a little slow, so just to let you guys know. Hopefully they fixed it, or I don't know, but it's a little slow. We're still broadcasting, but I'll record. I think this is our class. Is that our class? What section are you guys? 16324. Okay, and it's statistics. Yeah. So anyway, all right. Now we do have a question. I believe it's on the assignment and histograms. Okay. Oh, it's slow. Darn it. Can't share with you guys that. All right, it's gonna be slow. So I guess I'll just use language. I guess. And which one is it? Do you guys remember? Summary of data, yes, the summary of data. Maybe it's at the mean or something. I don't even want to tell it to do two things at once. There's a picture of a histogram in Desmos. Okay, now what that's a picture of is really a list of data, individual data. I did that so people can see the see. Continue recording. See what happens when I knew it was going to happen. By just changing the link. So internet is so slow, it's crawling right now. Anyway, I am recording. So ladies and gentlemen, I'll have to upload the video later for those who are, at home maybe. Okay, what were we saying? When you're summarizing data and you look at the histogram in Desmos, there's gaps there, and there's a reason there's gaps. There's gaps because that's a list of individual data, like 0, 1, 2, and 3. So it's giving you the frequency counts for those. And Desmos didn't draw them without gaps. So you might say, well, what do you do? Well, you don't have to draw those histograms. I did include those. So don't draw those in Desmos. I think some people contacted me, said, hey, Mr. Judge, can you show me how to use Desmos to do that? And I said, well, you don't have to do that. So you don't have to do it. But you're right. They do have gaps, but it's just because this is how Desmos graphs their histograms. We graph them only with group data, really, and we don't have any gaps. Use boundary values. So anyway, that's answering that question, I guess. All right? All right. And I would like to show you, but I can't because the internet is so slow. It stopped our broadcast. All right. Let's get out of that mode. We're still in relative position. Right? So let's call that what it is, fall 2023, relative position. And what section? I know I keep asking, and I could look it up, but maybe you guys know. 16324. 16324. I have to do that because I have another statistics section, and you know what, ladies and gentlemen? With the other section, 16324. Anyway, you don't have to know the details, but fine. Remember what we worked on yesterday. What did we work on yesterday? We ended with those things called what? Yeah, Z values, and again, that Z formula is standardization formula, okay? Over what? S. And doesn't that give you what does that give you? 0, 1, 2. You say 3? 4? Yes. You see, we're talking about why you generalize with Z-scores. You might say, why do we even go there and use these Z-scores? What essentially you need, again, is that mean and the standard deviation, okay? So you need those things. This is the what? Mean, standard deviation for a data value. Mm-hmm. Yeah. Okay, and this is the real number line, and we'll put Z for Z-scores, and then you might even say, Mr. Judge, why do we have to generalize this and go there? And the answer is very simple. If I said to you guys, the height of men in the U.S., do you happen to know the height of men in the U.S., by the way, the average height?
5'7".
It's actually the mean. I think it's going to be 5'8". No. Yeah. I'm going to put it in 60. I'm going to put it in inches, okay? So Troll, the author of your book, has always reported the mean is 68 inches. What's the standard deviation? 2 point what? 9 inches. Okay. So here's the mean. Here's the what? Standard deviation. And so you might say, well, why do we ever have to just generalize this? So if I asked you guys a quick question here, okay? Because a lot of times I'm going to put, the person, I don't know, whatever, I don't know, name, right? The person's name, all right? Do you guys know Shaq? You guys know how Shaq is? You guys know who he is? What's Shaq's height? Thank you for knowing. How tall is Shaq? Actually, he tells everybody he's what? 7'2". Shaq supposedly is 7'1", but he tells everybody he's 7'2". Just goes to show, ladies and gentlemen, there's actually two things men lie about. Uh-oh. Let's be careful. Oh, now you ladies are listening closely. What are the two things that men lie about? We lie about our height, and that's actually women. Sorry, you have it wrong. Men lie about their height and how much money they make. Okay? There are certain things that men will lie about. Our height and how much money we make. Okay, I'm not going to say what women lie about, but I have heard through the years, age is one of those things. All right? Whatever. Who cares? Who really cares at the end of the day? So I'm just saying, you know how tall Shaq is. He's 7'1", but he tells everybody he's 7'2". So it just goes to show we always add an inch. So let's go with, how many inches is 7'2"? 7 times 12 is 84, plus 1 is 80 what? 5, okay? And our height is in what? Inches. All right, there you go. Here's the Ag's value. Now here's Shaq. Okay, let's compute Shaq's Z-score, his relative position. So if you said, well, how do we do that, right? Z equals X minus 68 over 2.9. All right, so there you go. Let's compute Shaq's Z-score. Let's kind of talk about that, because you might say, boy, I wonder what grade Shaq would get in terms of his height, right? So we're going to say here, we're going to say what? Put the what? Let's go back to all right, let's put what here? 85 minus what? 68 over 2.9. So here's what we're going to do. 85 minus 68 divided by what? 2.9. 0.9. What do you guys get
5.86.
to the nearest hundredths?
5.86.
Is that 5.86?
Yeah.
Well, 5.86. Go to the nearest hundredths. Z values are always to the what? Hundredths, which really means 2 decimal places here, okay? So if I said to you guys here, this is my favorite example. What grade can you give Shaq about his height? What's the problem, ladies and gentlemen? Shaq, okay.
He's outside of
Yeah, we can't give Shaq a grade because you can't say he's an A. Well, an A is, remember the grading that we did? I'm not going to colorize this. What I'm saying to you is Shaq can't get a grade in terms of his height. He's off the charts with a grading scheme. We can't say A, So what we do now is we look at this number and you say, what does 5.86 mean, right? 5.86, first of all, is what? Positive. What does it mean that it's positive? It is above the mean. Because where is your mean as a z value? Do you guys remember? The mean is 0. So what we say is Shaq is more than 5 standard deviations above the what? Mean. Okay? Because it's really between 5 and 6. Do you guys hear? You guys understand what I'm saying? But the value of Shaq's z-score, the meaning behind this number, is that it's more than 5 standard deviations. And we say above the mean because it's to the right, right? 5 is off the charts. I can't even label it. It's off my iPad. I can't even write it down. It's off my iPad. So the meaning of the number is what we're focusing on. All right, you guys okay with that? How about this? How tall is mini-me in terms of inches? And you might say, okay, Mr. Judge, who in the world is mini-me? You guys are probably born. You weren't even born yet. Yes, Austin Powers. Mini-me. Who's mini-me?
Dr. Evil's
How,
little
do you guys know how tall mini-me is? Gonna have to find. I'm not gonna even use the internet on the Wi-Fi because who knows what'll happen. We're gonna say what?
how tall is Mini-Me?
Mini-me. Oh, there he is. I wish I can use my. He's a character. Yada yada yada. Where's his name? He's somewhere over here. Me. Can't find it. Where is it? His name is, they usually have it. 2'8". Thank you. 2'8". How many inches is 2'8"? 2 times 5 is 24, plus 8 would be what? 32 inches, okay? Let's check mini-me's height. You say, how do I do that? Well, plug in now what number for x, because it's a data value. Plug in 32. So in our calculator, ladies and gentlemen, we're going to say what? 32 minus 68 divided by 2.9. What is this going to be?
-12.
Negative what? 12.41. Is that true? Z-scores. Okay. Negative 12.41. Let's write that number down And I'm going to describe to you guys what it really means, negative 12.41, right? Well, first of all, negative 12.41, ladies and gentlemen, these are the z-scores, right? Is because it's negative, right? You know what that means?
12.41 less than 12 standard deviations.
Well, what do you think a negative z-score should be? Anything to the right of 0, okay, is above the mean, okay? See that? And I wanted to use pink. Is that pink? No. So anything to the right of 0 is positive. It's above the mean. If you're to the left of 0, you're negative. You are below the what? Mean. So that negative number means you're below the mean. Okay, let's go further now. How far below are you? You are more than what? 12 standard deviations. Now, below the what? Mean. So now you're below the mean. You are what? Below. That's negative. Negative is below the mean. Positive is above the mean, negative below the mean. So we're trying to communicate really this relative position numerically as a z-score. What do you think that actually means? Let's kind of think about this, ladies and gentlemen. You know what it means? Who, Shaq or Mini-Me, is more relative position? Who do you think is more rare? You're going to be more likely to see more Shaqs than Mini-Me. Why? It's not a relationship between positive and negative necessarily. It's further away from 0, the mean. So, I mean, even though it's to the left, it's much further away from the mean, 0, than Shaq. So Mini-Me is a lot further away from 0. That's all. You guys hear what I'm saying? So if you have a z-score with your height that's like negative 8.96, that's below the mean, and it's more than 8 standard deviations. Yes?
Why would you say negative 12.41 is more than 12?
No, it's not more. But here's the deal. If I said to you, right, and I can't even draw it because it's off my iPad. What's so special about 0 as a z-score? That's 0 represents the mean as a z-value. So if you go to the right or the left, right, doesn't matter. Who's further away from 0? Mini-Me, this is Mini-Me's height. Mini-Me is further from what? 0. Shaq is actually closer to 0. Okay? I know they're in opposite directions, but that's not the point. We're saying who's farther from 0? Mini-Me, because Mini-Me is farther from 0. That his height of being more than 12 standard deviations now below the mean is actually more of a rare situation. The further away you are from that mean as a z-value, the more rare that is. Even if it's above, like you can say, what about being above? Well, you're above the mean. So Shaq is. We're gonna give you guys some language here. Okay, I'm gonna give you a definition. Definition now of an unusual z-value, which is really a data value. Okay. On what? Usual. Okay. We say z is unusual if the absolute value of z is bigger than what? 1. This is what it means to be what? An unusual z-value. This is our definition of being unusual. The absolute value is bigger than 1.
Does that include
Yes, because the absolute value, you know what the absolute value is? How far you are from zero. So let's go back and double check here. Let me actually give you guys a little bit of math here, all right? It's a little bit of math. You go, what do you mean? Do you guys remember the absolute value of zero in intermediate algebra? You know what that meant? That meant z was less than -1, or z is greater than what? +1, okay? That is what all of this what means. So if you were to graph this, oops, I'm sorry. I gave you the wrong definition. It's not 1, it's 2. I apologize. Okay. On your scale now, as you graph, because in intermediate algebra, they had you graph these inequalities. There are absolute value inequalities here. 1, 2, 3, right? 4, -1, -2, -3, -4. So anything bigger than +2 or smaller than what? -2. Okay. This is where the z-scores, which it really is your x-scores, are what? Unusual. So here's what I'm getting at. Shaq has a z-score of a positive 5.86. Is Shaq's z-score unusual? Is that an unusual z-score? You think that is? Yes. So Shaq has an unusual z-score. We'll say yes or no. This is a yes for Shaq. Now, you might say to me, why, Mr. Judge? Well, what happens if you plug in that number in your absolute value, right, of 5.86? Okay. So you can do two things. You can plug in 5.86, which means the absolute value of 5.86, is that bigger than 2? That's 5.86. Is that bigger than 2? Yeah. Yes. If you were to graph it, I know I can't, but it might be over here somewhere. You guys see what I mean? This is where Shaq's z-score is. Just if you want, look at the graph. Anything bigger than 2 is unusual, and anything smaller than -2 is also what? Unusual. So Shaq is unusually tall, and Mini-Me, is Mini-Me unusual? Why? Because is Mini-Me to the left of that -2? Yes, it's really to the left. So Mini-Me is unusually what? Small. So you're seeing an example of somebody unusually tall and somebody unusually what? Small. Because what's the definition of a z-score to be unusual? The absolute value of it is bigger than 2. There it is. There you go, ladies and gentlemen. That's what it means to be what? Unusual. Okay, now you say, Mr. Judge is 5'7". How many inches is 5'7"? 67 inches. 5 times 12 is 60 plus 7. Okay. So let's find Mr. Judge's what? Z-score. Let's see if he is unusual in terms of his height. Plug in 67, okay? Let's see if he's unusual. Plug that in. What do you end up getting? You get what? 67 minus 68. You close that, and then you divide by what? 2.9. What do you get?
Negative 0.34.
You say this is negative 0.34 to the nearest hundredths. Okay. Let's figure out what this really means here. Okay, let's talk about that. Now, first of all, because it's negative, that score for Mr. Judge, his height, negative 0.34, is below the mean. Is that true? Why do you know it's below the mean? Negative numbers are to the left of zero. Zero is where the mean is. But you might say, I mean, and where is he on this graph? Oh, we can put him. Easy. He's like over here. Right? Isn't negative 0.34, it is to the left of zero where the mean is. Okay? It's below the mean. But is it past 1? No. So here's what we say. That z-score is within. It's within 1 standard deviation below the mean. Because we can't even say more than 1 standard deviation because it's not bigger than 1 or less than 1. It's not smaller than 1. So this is kind of anything that's in that range, we just say within 1 standard deviation, if it's between negative 1 and 1. Now notice, if you had to give Mr. Judge a grade for his height, he would be what? He is in the C range, meaning he's in the range of a kind of an average height, if you guys want to think of it that way. But is Mr. Judge's height unusual? No, why not? Because it's not in the green. It's not bigger than 2, and it's not what? Smaller than negative 2. It's not in that green range. So if they say, is this an unusual z-score, what do you get to say? No, it's not unusual. Easy peasy, yes.
So if we were to draw a comparison back to when we were talking about grading on a curve, it would be the same as saying, assuming the curve, anybody getting an A or an F would be unusual.
Yes. So you're right. In the terms of grading on a curve, remember we talked about that yesterday. It might even be here. Where is it at? Section 16324. All right, there we go. There we go. Remember all of these scores here? No one on grading on a curve is unusual. No one stands out either above the mean or what? So all of these z-scores are, you would say no to being unusual. No. But to answer your question is yes. In this picture, anybody that got a grade in this picture, if I now go to the z-scores on it. Oh, where's the z? Over here in this picture. Okay. Anything above that 2 or below the negative 2 is unusual. So it would be unusual if somebody got an A and unusual if somebody got an F. What do you guys think? You guys see how that works? So z-scores are really important in measuring relative position and graphing them on that real number line because you want to determine who's unusual and who is what. Yeah, you can say not unusual, which really implies usual, but we just say no to being unusual. All right, you guys okay? So it's going to be either a yes, no answer. Is it unusual? Yes. Is it unusual? No. How do you know? If it's bigger than 2, the z-value is unusual. If it's less than -2, the z-value is what? Unusual. All right. Anybody have any questions? It's your question. Should we continue with height of men, or should we change the subject to weight of women? Don't go there, Mr. Judge. I had the last class in summer, we did some z-values. I have to ask Chat GPT, hey, Chat, what's the average weight of women in the United States? Because I don't have that data. And it gave me an answer. Should we do that question? Because I do have a scale here. We can gather real life data. See, now people are like, no. Now I don't like your data. I used to laugh at, everybody would laugh years ago. I would do this. They would laugh when I ever did the height of men. I go, Mr. Judge, it's 5'7". You hear all the, you hear all the laughing in class. And I'm like, oh, you just wait. We're going to change it to the weight of women. And then all of a sudden, what happened? The laughing ended. So we can change the scenario. Anybody have a question on that one? Yes.
So would there be like examples about speed?
About what?
Speed?
Yeah, I mean, like for example, if you say, can I see an example? Let's do an example here, okay? Speed on the freeway. I don't know, speed on where?
The Autobahn.
What's the speed on Hal's Highway? Is there such a thing? I would check online and show you guys, but ELAC Highway. Okay, so if they said to you the average speed is 68.6 miles per hour, and the standard deviation, ladies and gentlemen, is 5.2 miles per hour. So they gave you the what? What did they give you? The mean and the what? Standard deviation. Okay? And then you decide to go out and gather some data, right? So remember, your data is an X value. So you're outside and you're clocking, maybe you're a CHP officer. You ever see them with the speed guns? Yeah. And they go, oh, somebody went by and what was their speed? 65.8, or yeah, 65.8. This is an MPH. Somebody else goes by and you say, okay, remember, these are the X values. And they're clocking people. Oh, 78.7, 80.9, 42.1, and then somebody driving by at 100.3. Okay? So these are all the data values for some CHP officer. I'm going to say to you, compute the Z values and tell me if any of them are on what? Usual. That's a yes or no answer. And then this is also, remember, we're going to give z-scores to the nearest what? Hundredths.
Below the 78.7, is it 80?
80.9. 80.9. Okay? Now, I made this up. There is no such thing as ELAC Highway. Maybe there is a Hal's Highway. Does anybody know? I don't know why I have that. Is there a song? There is? Hal's Highway? Oh, there you go. Okay. There's some people with some taste, I guess. Taste in music. Good for you guys. All right, we're going to give you guys some time on your own. Compute the z-scores. Approximate them to the nearest hundredths and tell me if any of them are unusual. All right, let's get out our clock somewhere. Okay, let's ask you guys. We're going to find all these z-scores, but before we do, was there any data value that was unusual? There were? How many? 3 were unusual? Okay, well, let's double check then. How do you approximate z-scores again? Hundredths, 2 decimal places. Okay. Now, here's the thing. Z. What is your z? All right, let's do the formula here. Z equals x minus, what's the mean? 68.6 divided by, what's the standard deviation? Okay, so what you're going to do is you're going to find the z-score for every one of these x values. These are all data values, okay? And we're going to use our TI. We're going to approximate to the hundredths. But I just want to color coordinate this to remind you the mean goes here and the standard deviation goes here. Okay, let's get out this TI, okay? I'm going to put them here. Now, the first one, 65.8 minus 68.6. Close that, divided by what? All right, what do we get here? Let's see. Negative 0.5 what? 4. Is that true? It looks like you guys are correct. Is that unusual? No, because if you were to plot this, I know they didn't ask you to. Yeah. 0, maybe 1 here, negative 1. Negative 0.54 is like right over here. And it's not unusual. It's not past negative 2. Okay, it's below the mean because the mean is always 0 as a z-score right in here. All right, now let's get the next one. 78.7. Here we go. 78.7 minus 68.6. Close that. Divided by 5.2. What do you end up with? 1.94. All righty. Is that unusual? No, because it's not past 2. All right. So if this were 2, positive 1.94 would be over here. It's not past 2. Okay. We're going to put some of these 3, 4, negative 2, negative 3, negative 4. Okay, put 80.9 now. Minus 68.6 divided by what? 5.2. And what do you guys end up with? 2.3 what? 7. All right, let's put that over here. 2.37. Okay, is that unusual? Yes. All right, and so where will we plot that? Somewhere over here, maybe. I might have to put it down over here because sometimes it's just not enough space. The point I think I want to make is anything that's above 2 is considered unusual. Okay, and 2.37 certainly is above 2. It's unusual. Now, technically we can say this is more than 2 standard deviations above the mean. The meaning of the whole number 2 is this number of standard deviations. So this is more than 2 standard deviations. Yes, it is unusual. Okay, let's check 42.1. Parentheses, 42.1 minus, what's this? 68.6, close that, divided by 5.2, and what do you end up with? Negative 5.1. 2.10. Oh, notice this. Is this unusual?
Yes.
Yes. So that's an unusual score. In fact, ladies and gentlemen, it's going to be, let's put these in red. Maybe they stand out, right? Negative 5.10. I'm going to say to you guys, anything again below negative 2 is considered unusual. Okay, so I'm going to put 2.37 here in red just so that it stands out, okay? So you guys can see these things. So you're right, it is unusual, and it's an unusually slow speed because that's, to the left of 0, and it's more than 5 standard deviations below the mean. Now let's check to see how much somebody who goes 100. Let's find that out, 100.3. So parentheses. 100.3 minus what? 68.6. Close that, divided by 5.2, ladies and gentlemen. You get 6 point what? 6.10. Now, all right. So let's go back here. Is that an unusual speed? Yes. In fact, darn it, I might be off the charts again. I hate when I'm off the charts. 5 and I'm off the charts, ladies and gentlemen. But that speed of 100.3 is more than what? 6 standard deviations above your what? Mean. Easy peasy lemon squeezy. All right, you guys okay with that? All right, pretty good. Now I'm going to ask you guys some more questions on relative position here. Here's what we're going to say. Who scored relatively better on their exams? Of course, Hannah Montana had a data score. Well, first of all, the mean of that was 100.2. Standard deviation is 15.8. She scored 120 on the test. And, we have another test. Hannah and who? What's the other one? Miley Cyrus. Okay, she took another test. She scored 98.5. Standard deviation is 12.1. And her test score was actually going to be 105. So essentially, there's 2 different tests. Hannah has her test. I don't know, maybe it's a chemistry test, who knows? Maybe it's a dance test, it's a singing test. But we want to know who scored relatively better. This is about relative position. Relative position. So you might say to me, well, how do I do that? Well, you're going to compare z-scores, okay? Comparing z-scores. So you're going to have z equals x minus, what's the mean again? 100.2 over 15.8. Z equals x minus 98.5 over what? 12.1. I'm going to have you guys try this out as I look something up really quick. think something's down. Okay. All right, let's see what you guys get here. Okay, so we're going to compare these scores here. Is that internet down? Weird. There you go. So you're going to have here, ladies and gentlemen, what's the data score that you enter for Hannah? Right? If we go back over here, right, what's that data score going to be? This X value goes here. This X value goes where? Here. So plug that in. 120 and what? 105. $120 minus 100.2 divided by what? And what do you end up with? 1.25. Okay. So you go, okay, this is 1.25. All right, now what about the next one? We're going to compare, put an open parentheses, 105 minus 98.5. Close that and divide it by what? What's this? 12.1 now. What do we end up with?
0.54.
Oh, 0.54. All right. Let's go back and take a look. Okay. Okay, so who would you say scored relatively better on the test? Who has bragging rights? What do you think?
No, Hannah, because she's positive.
Well, let's think about this here, right? Let's go to let's go over here. 0, 1, -1, 2, -2, right? So if I said to you guys, okay, Hannah in orange, 1.25. So 1.25 might be over here. Is that right? Yeah. Okay, now in green, Miley's score, I know it's a different test, but this is 0.54. What do you guys know about the z-score of 0 here? What do we know? Isn't that where the what? Is that where your mean is?
Yeah.
Aren't these z-scores? So who scored relatively better? What do you guys think? 0 is where the mean is. You'd probably want a score that is probably what? First of all, that is further away from the mean?
Further away in the positive direction.
That's right. So who is that?
Hannah.
That's Hannah. Is that true? She's orange. So this person here, the person that scored 1.25 did relatively better. They're higher in terms of what? Their z-score. They're further from the mean. So if you're taking a test, don't you want to be further from the mean? You guys see what I'm saying? And are any of these scores unusual? No, they're not unusual, are they? You guys know what I mean? Unusual. All right. What if you have a third person? Who's the third person? Oh, let's think about it. Justin Bieber. What do they call him? JB? Oh, JB. You ladies like JB? Good for you. His music. JB, Justin Bieber. Guess what? Justin Bieber. The class average is 50.8. Standard deviation is 4.2. And JB, his test score, ladies and gentlemen, is about a 58. Okay? Let's see where JB. Now, what color should we give JB? Green. Well, we already have green. We have orange. Maybe purple. JB is purple. All right, JB. Let's see. How do we use that formula, right? See who scored relatively better. Z is what? X minus. What's the mean? 50.8 over what? 4.2. Now remember, this is JB's X value. That's his data score. So even though they all had different tests, we can see who scored relatively better. Good old JB. Now, let's see, Justin Bieber. 58. Let's go here. 58 minus 50.8 divided by 4.2. What do you get? 1.7 what? 1. $1.71. Oh, take a look, ladies and gentlemen. Where's 1.71? Right, but it's certainly above 1.25. Is that right? So guess who scored the best, relatively speaking? Good old JB. Justin Bieber scored relatively better than Hannah Montana and Miley Cyrus. You guys okay with that? You guys see what I'm saying? Isn't that interesting? We could even compare. You say, why? Why did JB score better than all these, or not all these, a couple of these other situations? Is further from where? The mean, and it's positive. Yeah, it has to be two things. It's in a positive direction because he could be further from the mean in the negative direction. But that's still not good enough. Okay? Like, for example, if I added another person. Say who? Donald. Donald Duck. Class average for Donald Duck was 62.1. Standard deviation was 8.7. And guess what? Donald Duck scored 45.3. Let's see, relatively speaking, X minus 62.1 over what? 8.7. Okay, Donald Duck. What color should we use for Donald Duck?
Yellow.
We'll use, is Donald yellow? Hey, you can see, good, you can see the yellow. Good. So let's plug in that X value for Donald, 45.3. 45.3 minus 62.1 divided by what? 8.7. What do you guys end up with? Negative 1.93 to the nearest hundredths. Okay. All right. Negative 1.93. So let's get our yellow highlighter. Okay, where is Donald at then? It's below 0. Is it past negative 2?
No.
No. This is where negative 1.93 would be. Boy, you can't even see it. I can't see it, but sort of see it. Can you guys sort of see it? Or should we maybe do it this way? We can do it this way. Yeah. You go, okay, I can see it a lot better this way. Okay, here's my location. All right. So, ladies and gentlemen, what do you know about Donald? You know, you could say, hey, Donald is actually further from the mean than all of them. Donald is further from 0. But what's the problem? It's below the mean. So could Donald say he scored, or is Donald a he or she? Okay, did Donald, I guess there's Daisy and Donald. Okay. So Donald, ladies and gentlemen, is further below the mean. Could Donald say he, because he's further away from the mean? Because he's further away from the mean, can he say he did the best?
No.
Why not?
It's in the negative direction.
It's below the mean. How do you know it's below the mean? It's a negative z-score. What is this? What's so special about a z-score being 0?
That's the average.
It's where the mean is. Because we had to generalize. You guys see what I'm saying? So this is a very good setting and scenario for you to start to compare. I'm going to use the phrase, relatively speaking. And to compare, relatively speaking, let's see if our internet is any good. You guys aren't in calculus yet. Oh. Let's go. Let's take a look. Relative position. What do you think we got started talking about? Relative position. Let me double check this worksheet. Oh, relative position worksheet. Here's your video solutions. And then you have a z-value worksheet. Oh, man, look at that. Oh, z-value worksheet. Okay. And then you got some solutions, too. And let's say you wanted to watch some videos on it. These are some other lectures on it, in case my video went down. So let me go back. Relative position, z-values. So I'm going to go over here, copy, assignment. Here we go. Now I'm going to put the link here, so by now you guys know. Now, earlier I was going to kind of play for you guys the how to turn in your homework in Cam Scanner Plus. You guys know what I mean? So you might say, hey, Mr. Judge, how do we turn in our homework? Boy, I mean, I have a link here. Let me find it. You guys know where the link is? It's here. How to download Cam Scanner Plus and how to upload. So maybe you need to download Cam Scanner Plus. Okay? So remind me tomorrow, because I'm going to put here in your homework. Maybe I want to put that there, okay? I'm going to put edit, how to download Cam Scanner Plus. If you and don't get the expensive one. Get the one that's $1. So how to upload your what? Homework. You want to batch it? What is batching? You put it as a single file. That's called batching. And then you want it to be compressed. You say, what is compression? Well, you got to compress it because your bandwidth at home, who knows? And maybe you're using bandwidth not even at home. You're using satellite or whatever that is called. So you might want to shrink your file PDF. So I'm going to put that there too. I'll try to play it for you guys tomorrow. But nevertheless, if you want to see it now, there's how you do it. So this is how you're going to upload it in where? Homework 1 in Canvas. It's going to be there. And as a batched. What does a batch mean? Single PDF file. You probably have to compress it. And so those features are in Cam Scanner Plus. They're very nice. I know my calculus class was, oh, yeah, I like Cam Scanner. All right. Anybody here have it? All right. Okay. Do you like it? Maybe okay, good for you. So, hey, you know what? Look at them. We'll look at them tomorrow. And stay safe. And we'll see you guys later.